So the next topic we're going to cover here is Java 8 Lambda expressions and method references. And we're going to show them in a bunch of different ways. So we're going to show how to create a closure as well as to sort elements in a collection. So first of all, what is a closure? A closure is a very cool data structure that will essentially associate a scope with behaviors and allows you to be able to bind values to variables or parameters in that scope. And so we're going to show how you can do this with Java Lambda expressions. So here's a class we call closure example. And you can see it has a private field that just keeps track of some count. And you'll see why we have a private field in a second. And then we have a factory method here that's called make thread closure. And as you can see, it's passed in, takes as parameters a string and an integer. And it's going to create a new thread. And then it's going to have in that thread a Lambda expression, which is just essentially an unnamed block of code that has some computation associated with it. And this unnamed block of code is going to go ahead and print out the parameter, the string, and then it'll also include whatever the current value of mres is, adding to it the parameter n. And this shows off a bunch of cool things, which we'll talk about in a second. And so what's interesting about this is that the thread that's returned will actually, when run, invoke the operation that's enclosed within the Lambda expression that's passed as the parameter to the thread. And again, hopefully this is review, but a Lambda expression is basically just an unnamed block of code that optionally has parameters or not. In this case, there's no direct parameters to the Lambda, although we can access variables in the scope, the enclosing scope, because we're making a closure. And we use this to basically kind of bundle up some computation that will be run in a different context at a different point in time. So we make a new thread with this information. And then down here, the constructor for closure example will make a thread closure, passing in a string and a number. We get back a thread, we start the thread, and then we join that thread when the thread is finished. So that's a nice example of closures. Now, Java doesn't really have super duper sophisticated support for closures, but it's close enough for our purposes here. And it also demonstrates some cool uses of Lambda expressions, where you can see that this is basically what's called a function descriptor that has the signature associated with the runnable functional interface. So again, if you need a refresher on some of these concepts, we'll talk about functional interfaces in more detail in a second. So we can run the closure example here. Then we're also going to show a bunch of techniques for sorting. And this is kind of a fun example because it demonstrates the difference between the traditional anonymous inner class approach, which you had to put up with in earlier versions of Java, with Lambda expressions, which are more advanced, and then finally method references. So let's take a look at each of these things in turn. As you can see here, in every case, we're going to sort this array here called name array. The way we're going to do this, first we're going to show how to sort using an inner class approach, which is the legacy, nasty way of doing things. We make a copy of the name array. Notice the use of arrays.copyof. This is a technique you should keep in mind when you do your first programming assignment, because that technique comes in handy there too. And then we're going to use an anonymous inner class to implement a comparator. So you can see we say arrays.sort, and we pass in name array copy, which is the copy we made, and we pass in a comparator. And you can see the comparator here is going to be very verbose. We say new comparator, string, open, close, open curly brace, public int compare, open paren, string s, comma, string t, close paren, blah, blah, blah. And finally, we get to the part that matters, which is the computation, which is going to compare the two strings after first lowercasing them. So that's how we're going to do the comparison. And then down here, we're going to go ahead and print the results out by taking the array copy and converting it to a list and using println. So that's kind of the old school way of doing things. This code, of course, continues to work in modern Java, but nobody wants to write stuff like this. It's very verbose and causes much carpal tunnel syndrome. Here's a somewhat more concise way to do things using Lambda expressions. You can see here, this is way more concise. Let's see if we can get them both on the slide at the same time so you can see what I'm talking about. Let's see, I'm not sure if we can get them entirely on the slide, but you can see here that, there we go, I think that's pretty close. So here's what it looked like with the anonymous inner class. Here's what it looks like with a Lambda expression. So in this case, we're going to use arrays.sort name array copy, comma, open paren s comma t close paren. That's the parameter list, and that uses type deduction to figure out that those are strings, string s and string t. And then we have an arrow, which is just the syntax that says what follows is the body of the Lambda expression. And what we do there is we just say s dot compare to ignore case t. So that'll do a case insensitive comparison between string s and t. And then we print the results out. Now let's show the coolest way of doing things. This is using method references, and we're going to show a couple different variants of this. So this particular example here makes a copy of the array, and now we're going to use arrays.sort name array copy, comma, string, colon, colon, compare to ignore case. So unlike before, where we used the Lambda expression, you can see what it looked like there. Wasn't too verbose, but it did have a little bit of extra stuff in there. This is really straightforward. We just say sort by using the compare to ignore case method. And what's cool about this is if we want to change this to sort comparing case, boom, there you go. And this is very clearly an instance of the gang of four strategy pattern. So this is using method references to implement the strategy pattern in modern Java. So I love it. It's great. Use method references whenever you possibly can. Down here, you can see what we do is we take the name array copy, we convert it to a stream using the of factory method operator on stream, and then we use the forEach method on stream, which is a so-called terminal operator, to pass in the system.out print method reference, which prints every element out. And then just for kicks, we do the same thing, except in this case, rather than using stream of, we use list of, and we convert the array into a list, and then we use forEach on that. And it turns out that this is the Java 8 iterable forEach method. So the one that we had up here was the Java 8 stream forEach method, which is a terminal operation. And this is the Java 8 or modern Java iterable forEach method, which works on an iterable or a collection or a list in this case, as opposed to on a stream. And believe it or not, there's actually semantic differences between forEach on a stream and forEach on an iterable or a list or a collection. And that has to do with the semantics if you're using parallel processing, like a parallel stream, where the results of forEach are undefined. The order in which things are processed is undefined, which is good. You want it to be undefined. It means that it doesn't have to be in strictly sort of from beginning to end order, which gives you more flexibility and more parallelism. So that's the second example that illustrates things like closures, Lambda expressions, method references, and compares and contrasts them with the old school way of doing stuff.